Hi, time for the second method for solving systems of equations. Last time we did the substitution method, but the big problem with that method is sometimes it is difficult to get one of your variables isolated. And even if you can, sometimes you get just really large unwieldy fractions like 1783 or something. And to then plug that into another equation and to try to solve is unwieldy at best and leaves a lot of room for mistakes. So there's the second method, the elimination method, which, as the name implies, the goal is to eliminate one of your variables, and from there solve for the one that remains. Just like when we did the substitution method, I'm first going to give you kind of a rundown list of the steps that can be taken to do this method, and then when we do the examples, you can kind of follow the steps one by one and see what takes place. Alright, so that big idea. First off, well, the goal for elimination is to have two of your variables to have opposite coefficients. So for example, 5x and negative 5x, where the first equation could have a negative 2y and your second equation should have a positive 2y. Now sometimes in order to get that, you have to multiply one of your equations, or maybe both of the equations, by some numbers just to get common multiples that will cancel out. And we'll see some examples of both systems where you don't have to do this and where you do have to do this. Because these are equations, the whole point of equations is that the two sides are balanced. When you add your two equations together, the result will be another balanced equation. Now if you did step one right and have your opposites, when you add these together, those opposites will cancel out and one of your variables will be eliminated. Once that's happened, you solve for the variable that's still there. Once you know its value, from there it's just like the last method. You take that back to one of the original equations, plug it in, and see what the variable that you had eliminated is going to be. Alright, so let's go to some examples. Hopefully you can see this. I have the system 3x minus 2y equals 14 and 2x plus 2y equals 6. Let's start with blue. Now, step one was you needed to get opposite coefficients. Luckily, in this particular problem, I have a negative 2y and a positive 2y, so I already have opposites. Okay. Second step. Add these two equations together. 3x plus 2x is 5x. Negative 2y plus 2y cancel out, so the y's are gone. 14 plus 6 is 20. So now look at the equation I have left. 5x equals 20. Well, that's easy. Divide the 5. X is 4. Now, I'm going to take that and I'm going to plug this into, it doesn't matter which equation. I'm going to plug in the second one. 2 times 4, now that we know what x is, plus 2y equals 6. Solve this like you would any equation. 2 times 4 is 8. Subtract the 8. 6 minus 8 is negative 2. Divided by 2, y is negative 1. Just like before, wrap it up together. X always comes first. Negative 4, or positive 4, negative 1 is the solution to that system. So we have step one, made sure we had opposite coefficients. Step two, added those together, and then we solved. So that's step 3 also. Oh, oops. See that right there? Then step 4, we did back substituted. We took the 4 that we found for x, plugged it into one of the original equations, solved for the y that we had originally eliminated, and got our answer. Alrighty. Another example. Same idea. But as we look at this example, we don't have opposites. We have 4x and 2x, a 9y and a 3y. Doesn't matter which variable we get rid of. I think this time I'm going to get rid of x. So that's what I want to eliminate. But in order to get opposites, I need to multiply the second equation, the whole second equation, by -2. So I'm going to have the 4x plus 9y equals 1. So I haven't changed that first equation yet. And we'll multiply every value in the second equation by -2, because that's going to give me -4x right there. -6y, and -1 times -2 is +2. All right, so now that I've multiplied, I can add my equations together. 4x and the -4x eliminate each other. That's why I multiplied the second equation by -2. 9y minus 6y is 3y. 1 plus 2 is 3. Well, divide off that 3 and you get y to be 1. Beautiful. Let's see here. It doesn't matter which equation I do. I think this time I'm going to do the first one, just because. 4x plus 9 times 1 equals 1. 4x plus 9 equals 1. Subtract the 9 from both sides. 4x equals -8. Divide by 4. X is -2. So my answer is -2, 1. That point is where those two lines will intersect. So in this problem, because of the way it was originally set up, step 1 was both longer and more important. As you've probably already found out by doing substitution method, you need to be careful. Take your time, show all of your steps, and try to make sure you're not making any arithmetic errors. And also, for some of you, look at how much of this paper I'm using. These are not small problems that you can squeeze into one line. That was not a challenge for you to try to squeeze them into one line. Use the paper to your benefit. Spread it out a little bit so you can easily follow the flow of events from the original setup to where you added things, to where you solved, to where you back substituted, to your final answer. Everything's nice, relatively easy to follow. You don't have to squint. Don't have to try to read it hieroglyphics. It's all right there. Remember, the point of showing work is not because math teachers are being mean. It's not because we want to look and figure out things. We've already figured it out. We want you to be able to communicate what you did. Showing your work is how you communicate it. You can easily see you multiplied by the -2, added the equations to get 3y equals 3, you got y equals 1, you substituted. Now you don't need all the arrows that I drew, because I can follow this, but they're not wrong either. Okay, next example. Ah, well, again with this one, switch back to blue for step one. I think I'm going to eliminate my x's. I need to multiply that first equation by 2. So 2 times 4x is 8x. 4 times 3y is 6y. 24 times 2 is 48. I'm leaving the second equation alone. Now sometimes you will have to multiply the second equation by something also. Alright. The important step, which is usually the shortest step, is when you add, the x's cancel. 6y and 6y is 12y. 48 minus 36 is 12. Oh, that's nice. Divide, you get y equals 1. Beautiful. Switch to green for the back substitution. Doesn't matter which equation you plug it into. I think I'm going to plug it into the first one again. 4x plus 3 times 1, replacing that y with the value we just found for it, equals 24. 4x plus 3 equals 24. 4x equals 21 after I subtract 3 to the other side. And when I divide, I get the fraction 21/4, which is 5 1/4. Oops. 21/4, comma 1. And yeah, you can get fractions. But they're usually easier to deal with in the elimination method because they won't pop out till right near the end, usually. Unlike in substitution, where your fractions are going to happen right away, and you'll have to work with them the whole problem through.